Okay, 4.3, area, volumes, prisms, and cylinders. I've broken up chapter 4 for surface area and volume into many different slow, small steps just because there's a lot of information and it's very easy to get confused. We're going to first start off with something similar, which is basically prisms and cylinders. A prism, it could be a square prism, rectangular prism, triangular prism. It's basically a 3D shape. When it comes to your volume, you have to consider the area of your base, so the area of the whole base down here, and you're going to multiply it by your height. Volume in more ways is often easier than surface area. Because for volume, for almost all the calculations, you're going to go the area of your base, so however you find area, for in this case would be length times width, multiplied by your height dimension. For your surface area, you can think of it as breaking it and drawing your net, and then finding the surface area of each of those nets and adding them together. Or if you can just think about them, so well, I know I have, my width over here times my height would give me the surface area of this rectangle here. I've got the other rectangle on the other side, so I'm going to do that twice. So width times height plus width times height, plus my length times my width twice for this area. And last, I'm going to have my length times my height for this upper rectangle, and again twice. So your surface area, you just want to make sure you find the area of each of those panels and then add them all together. In our example, I've given you guys still a rectangular based prism, but this one's almost more square based. So for volume, we're going to find the area of this base, area down here, which we know is 5 by 6. So really it's going to be length times width times our height. So volume is going to be 5 times 6, again this will be meters and meters, times our height, which is 10. Five times 6 is 30, multiplied by 10 should be 300. So our volume is going to be 300 meters cubed. Remember how we said surface area was always something squared? Well, volume is always going to be cubed, because you're going to have the same three units multiplying by each other. Surface area will take up a bit more room. So, for surface area, we're going to do our width times our height. So 5 times 10 plus 5 times 10, followed by our length times our width. So length times width, 5 times 6, plus 5 times 6, plus our length times our height. So 6 times 10, plus, I'll squeak it in here, 6 times 10. Next we have to add all these together. 5 times 10 is 50, so really we're going to have 50 plus 50. 5 times 6 is 30, plus 30, plus 6 times 10, 60, plus 60. 60 plus 60 is 120, plus 30 is 150, plus 30 is 180, plus 100 should be a total surface area of 280 meters, and because it is surface area, it would be squared. Just to check my math, I'll punch it to calculator. Yeah, I'm good. If you're having a hard time keeping track of which ones you have done, it is sometimes easier to draw the net and then do all the calculations per side and add it all together in a net. Cylinders are a little more complicated because, again, we have to deal with radiuses and diameters. So, for volume, it's the same calculation. It's the area of your base times your height. But we now have a circular base. So if you remember, area for a circle was pi times your radius squared times our new height. The surface area is a lot more confusing, because if you remember our net for this, when we break this down, we had a rectangular piece with our two circles. The area of these two circles is basically pi r squared, and it's going to be multiplied by 2 because there's two of them. The area of this rectangle is weird. It is length times width. Our width in our case would be the height, and the length is 2 times the radius times pi. And that's because when we wrap this long length around that circle, it is proportional to that circle. So really this is length times width, but there's a lot more math involved because it is a circle. In our example, we're going to have a very large container here. It's got a radius of 10 meters and a height of 3 meters. So this is probably some sort of silo or pool. Again, volume, area of our base, so area of a circle is pi times our radius squared times our height. So volume is going to equal pi times 10 squared times 3. I'm going to do 10 first in my calculator. 10 squared, or 10 times 10, which will give me 100. I'll multiply that by pi, and multiply that by 3. So I get a volume, which is 942.478. This was in meters, and because it is volume, it is cubed. When it comes to surface area, there's a lot of things going on here. Because there's this plus sign here, I'm going to put both sides in brackets just so I remember what is separated by what. So, for surface area, I'm going to go 2 times pi times my radius, 10 squared. I'm going to actually do that first. So, I'll start with 10 squared. 10 times 10 times pi times 2 gives me 628.318 meters, added to 2 times pi times my radius, which was 10, times the height, which was 3. So 2 times pi times 10 times 3 gives me 188.495, rounded up 6 meters. When I add these two together, I'm going to get a total surface area of 816.81 meters. There's a lot of math going on, but again, write out your formula. Your second time you've written out your formula, you write it out again, but filling in the information you know, going step by step, slowly add in information, and complete. 2 questions for your homework. I've given you a cube. I want you to find the volume and surface area of this cube. So every side is 6 meters. Probably the harder question. I want you to find the volume and surface area of the cylinder. The radius is 20 and the height is 5 meters. If you have any questions, again, I'll be online Tuesday and Thursday for tutorial. Otherwise, good luck.